Hi everyone, this is Taluk. I happy to wish you all the YouTube channel. I think the previous section we were learned about common ion effect, buffer solution and buffer action. Today we are going to learn about Henderson equation. What is Henderson equation? This equation is used to determine the pH of buffer solution, that is both acidic buffer and basic buffer. Okay, shall we? So in the previous section we are learned about what are the weak acids, common ion effect and buffer action. We know what is buffer solution. The pH of the solution remain constant even after the addition of small amount of acid or base. Okay. So today we are going to learn about the pH value, how to determine the pH value of buffer solution. So before that we have to know what is conjugated acid and base. We know already we discussed what is conjugated acid and base. What is conjugated acid and base? The species which differ by one hydrogen ion, that is called conjugated acid and base. Let us assume or let us take acetic acid which dissociated in water to form a acetate ion and hydronium ion. So what is the differences between acetic acid and acetate ion? See here only one H plus is differ between acetic acid and acetate ion. Similarly the water and hydronium ion, that is also differ by one H plus ion. So H3O plus and water are conjugated acid base pair. Similarly acetic acid is the conjugated acid of CH3COO minus. Here CH3COO minus is the conjugated base of acetic acid. Okay. So in Henderson equation we have to know the concentration of hydronium ion. We know what is the dissociation of acetic acids. So acetic acids dissociated to give acetate and H plus ion. For that reaction the dissociation constant Ka that is a dissociation constant equal to acetate ion concentration CH3 COO minus into H3O plus divided by acetate ion concentration. So what is dissociation constant? Which is the ratio of product of concentration of acetate ion and hydronium ion to the concentration of acetic acid. This is Ka, dissociation constants. From that we can calculate the hydronium ion concentrations. So hydronium ion concentration is equal to Ka into acetic acid divided by acetate ion. That is written as H3O plus equal to dissociation constant, that is acetic acid equilibrium concentration, acetic acid in equilibrium divided by equilibrium concentration of conjugated base of the acetic acid, that is base at equilibrium. Okay, clear? So we know the weak acid dissociated only to a small extent. Already we discussed in the previous classes, weak acid and weak bases are dissociated in small extent. Due to common ion effect, the degree of dissociation of weak acid or weak base is further suppressed, that is reduced. So, the equilibrium concentration of the acid nearly equal to the initial concentration of unionized acid. Here, the equilibrium concentration of acetic acid is nearly equal to the initial concentration of unionized acetic acid. Okay. Then, the concentration of the conjugated base, that is CH3COO minus concentration, is nearly equal to the initial concentration of the added salt. Clear? Right. So, let us write the equation number 1 like H3O plus, that is hydronium ion concentration, is equal to dissociation constant and molar concentration, that is initial concentration of the acids to the initial concentration of the added salt. Here, the concentration of acid and the concentration, that is molar concentration of the salt, represented the initial concentration of the acid and salt. So, the concentration of the acid and the concentration, molar concentration of the salt is taken as the initial concentration of the acid and salt. Right. So, next one. So, for taking negative logarithmic value for the equation number 2. So, what is equation number 2? Hydronium ion concentration is equal to dissociation constant and concentration of the acid divided by concentration of the base, that is salt. Okay. So, now we can take negative logarithmic value for the second equation, that is minus so what is the second equation? H3O plus ion, that is hydronium ion concentration equal to dissociation constant Ka into concentration of, that is initial concentration of acid divided by initial concentration of the salt. Okay. So, this is equation number 2. Let us take negative logarithmic value for both side of the equation number 2. Then we get, so minus log H3O plus equal to here minus log Ka, then minus log acid, concentration of the acid divided by salt. Once again I can write it, minus log H3O plus ion concentration, that is equal to minus log Ka into, minus log concentration of the acid divided by concentration of salt. So, this is the negative logarithmic value of equation number 2. Already we know what is pH. pH is the negative logarithmic value of hydronium ion concentration. So, what is pH? pH is the negative logarithmic value of hydronium ion concentration. Similarly, pKa, that is power of dissociation constant, that is equal to minus log Ka. So, P power x should be written as minus log x. Okay. P power x is equal to minus log of x, so that pKa equal to minus log of Ka. So, these two values, pH is equal to minus log of H3O plus I and pKa equal to minus log of Ka. These two values are substituted in equation number 2. Then we get pH is equal to pKa minus log of acid by salt. So, what is the second equation? What is the negative logarithmic form of second equation? Minus log H3O plus equal to minus log Ka minus log concentration of acid by concentration of salt. Clear? So, this equation can be written as pH instead of minus log H3O plus, we can use pH. Instead of minus log Ka, we can use pKa. So, the equation number 2 can be written as pH is equal to pKa minus log concentration of the acid to the concentration of the salt. Clear? Then we can change the sign, we can inverse the sign. So, then we will get here pH is equal to pKa plus log the acid by salt also inversed. So, we can change the, we can inverse the sign, mean the values, the denominator and the numerator also inversed. So, then we get pH is equal to pKa plus log acid by salt is changed to salt by acid. Clear? So, this is the equation for, acidic buffer, Henderson equation for acidic buffer. pH is equal to pKa plus log salt by acid. Similarly, the same method we can derive the pOH value. pOH value, that is Henderson equation for basic buffer, that is equal to pOH equal to pKb plus log salt by base. Okay. So, the Henderson equation for basic buffer is pOH is equal to pKb plus log salt by base. So, these are the equations for identifying or determining the pH and a pHO value for acidic buffer as well as basic buffer. So, I hope you are understand very well about the Henderson equations. So, we will meet next class. Thank you. Thank you.